With an interesting topic of jitter or delay variation coming up, let's explore it further. In this module, we shall once again look at the definition of delay variation, its variants, and a way of looking at the measurement of jitter, both quantitatively and mathematically. I want to quote an interesting statement from George Orwell's Animal Farm. He said that all animals are equal, but some animals are more equal than others. An interesting relationship or analogy that I want to draw from this expression in jitter is that there are some applications which claim to be resilient to jitter, while there are some other applications which are highly sensitive or claim to be sensitive to jitter. What is the exact way to determine if an application is truly insensitive to jitter? We shall see that during the course of this module. As we had discussed earlier, delay variation is actually the time variation measured as an average. Since different audiovisual applications are intolerant to jitter, and at the same time, both real-time and non-real-time applications exist on a network simultaneously, so there's always a trade-off which is required and usually is reached to ensure that in order to have high efficiency of the overall network, high volume applications such as audiovisual applications are at times given priority over low data rate, delay insensitive applications. As we had discussed earlier, in order to reduce and equalize the effect of jitter, many receivers incorporate jitter buffer that smoothens the arrival and playback of the incoming frames. Generally speaking, the jitter, depending upon its severity, is 1 to 2% of the overall delay, and hence, correspondingly, the jitter buffer is also sized at the receiver. Jitter can be classified into delay jitter and rate jitter. What is delay jitter? Delay jitter actually bounds the maximum difference in the total delay of different packets in the same time epoch. It means that we measure the incoming packets and their inter-arrival delay. Again, it is an assumption that the source is periodic. It is generating packets at regular intervals. This delay jitter is useful for interactive communication because we are interested in knowing exactly what is the overall jitter for incoming packets, and it is going to determine the overall size of the jitter buffer. The second category of jitter is the rate jitter. Rate jitter is the determining of jitter at various times. So this gives us the overall performance of an application. It measures the difference between minimal and maximal inter-arrival times, and this gives us correspondingly the rate, because rate is the reciprocal of time. This rate jitter is useful for the overall performance of many real-time applications, such as the video broadcast. It is important to observe that slight deviation in the rate actually translates to marginal performance degradation, and hence the quality of experience is not much compromised. This means that the rate jitter is a good representation, but not an exact representation of the performance of the network at a particular time because it is measured at different times. This diagram shows you the end-to-end connectivity between a host and a server. The host sits in a LAN, so does the server. And these two LANs are connected through routers, which are connected on a serial link. According to Ronnie K., Pragmatic Network Latency Engineering Fundamental Facts and Analysis, he described the analysis points at which jitter could possibly be measured. He goes deeper into his paper, but for the sake of brevity, we just look at 2 points A and B. What he does is, he tabulates the measurements, such as the packet IDs are given on the leftmost side, leftmost column. The packet IDs are enumerated there. The arrival of a packet at point A, the arrival of packet at point B, actually gives us the latencies in absolute form. But the relative latency is actually the difference between point B time measurement and point A time measurement. And then jitter is between two transmission sessions, one for packet number 1 and the other one for packet number 2. So jitter would be determined when we subtract the time that we observed for packet 2 and packet 1. And this can continue, so we can generalize that at any particular instance of time, the latency ln is actually the difference between the time which is measured at point B and time measured at point A.